Hello everyone, and in this video, we're going to focus on how we can start with by enabling TLS security for telemetry communication from iOS XR. So, the way we're going to achieve that is by enabling GRPC as the transport along with TLS security. So, this is going to be a practical sort of demonstration on how we can go about doing the same. So, let's dive right in. So, initially, we are going to generate the certificates required, right? So, let's start by making a new folder called certs. So, we'll house all our certs in this new folder. So I've created a new folder and I've dropped into that new folder, and we'll start by generating the private key. Now this private key we are going to generate for the root CA because we would need a root CA to sign our certificate signing requests, right? But if you're doing this for your own enterprise and if you already have a CA infrastructure, then you might want to sign the CSRs using that enterprise CA. Now, since this is for demonstration purpose, we are going to have a self-signed root CA, and we are going to use that root CA to sign our telegraf server certificates. So this is going to start this process by generating a private key with size of 2048. We can give it a passphrase. So this is going to save the key, along with the passphrase. So the next step, now that we have generated the private key, the next step is going to be to generate the PEM for the certificate authority. So what we're going to do is to use the ca.key file, and we are going to generate the ca.pem, and it's going to be valid for 365 days. Now, since we're using the ca.key that we generated earlier, we might want to key in the passphrase that we set in the previous step. We should key in certain basic parameters. So I'm going to start by entering um, a few basic parameters for this certificate that we're generating. So you can just give in whatever values that you like since it's for demo purpose, but in enterprise setting, you might want to key in these values more carefully. So I'm going to give lab for the organization unit name, and also the common name I'll go with lab, and a dummy um, email address would do here. So now that we're done, so this should have generated both the ca.key and ca.pem, which is the certificate. Now the way we can see the contents of this certificate is to use the OpenSSL library, wherein we are um, giving it the ca.pem file, and it would output the contents in a text format. So now you can see the content of this particular certificate. We can see whatever value that we keyed in for country, state, locality, organization, they all have been captured here. This is the subject of the certificate, and the CA flag for this certificate is true, which means that it can be used to sign other certificate signing requests. So now this completes the steps with respect to the root CA part. So now let's go on and generate the private key for generating the certificate for the telegraf server itself. So we're going to start the same step, wherein we generated the private key. So this time we are naming this telegraf.lab.key with the same number of bytes. And if you see the contents of this folder, you can see, we can clearly see that we've got one more private key generated. Now, once this is generated, we would need a configuration file. Now, this configuration file we would use to generate the certificate signing request, which would further then be validated by the certificate root CA certificate that we generated in the previous step. So I'm going to open an editor here, and I'm going to name this telegraf dot lab dot conf. Okay, so we are going to start this um, text file. So I'm going to copy a bunch of contents here, which would be relevant, and then I'll modify it accordingly to our requirement. So I'm just modifying the country and other stuff, based on the data that we entered previously, right? So location is going to be Bangalore, and organization net dev ops. Okay, so this is okay. So we have got pretty much all the stuff that's required, and here we would go ahead and change this um, to the IP address of our telegraph server. Now this looks good to me, so let me copy this to this particular file, and let's save this. So we've got the um, values keyed into the text file. Now let's go and utilize this configuration file, and based on this we'll generate the certificate um, signing request, right? So we have generated this CSR, so we can see the content of the CSR um, in the text format. So just to verify the contents of the CSR. So this is the content of CSR. We can see all the common name organization clearly spelled out. We've got also the alternate name, including the DNS and the IP address. So things look okay until this point, right? So now let's go on and further generate the actual certificate for the telegraph server. So the way we would do it is utilize this certificate signing request. We are also going to require the PEM file of the CA, and also utilize the private key of the CA, and we're going to output in the telegraph.lab.pem, and utilizing the telegraph configuration file that we generated previously. So we would want to key in the same passphrase that we gave earlier. So we have also generated the new certificate for telegraph, right? So we can of course see the contents in text format, and this is the newly generated certificate for telegraph. So we can verify the content. So this is the issuer part. So this is the authority which actually signed this certificate. So this the details belong to the root CA, and we are issuing the certificate for this guy. So this is the subject of the certificate, and the DNS telegraph.lab and IP address seems fine. It's under the subject alternate names, and you can see the flag for CA is false because this is not a root certifying authority, right? And so things could okay here. So now let's move on, now that we've generated all these certificates. Now coming to the configuration part, we are going to utilize dial out method, right? So when we're using dial out method for grpc, it's the XR router, which is basically sending the data towards the telegraph server. So now the telegraph server is going to be configured with a new certificate, right? But when this certificate is presented by this telegraph server to our XR router, the XR router needs to know this is a valid certificate. The way it can come to know that it's a valid certificate is by knowing who is the certifying authority, right? So we need to ensure that the root CA credentials, I mean the root CA certificate, is already present on the XR router. It's one of the trusted CAs for the XR router, and by this means we can ensure that when the telegraph server presents itself to XR, it will be able to validate it. So we're going to start by copying the PEM file that we generated for CA. We are going to copy this to the XR directory. So let me start by issuing an SCP command, and we are going to copy this to our router. So the router's IP address is .2, and we are going to copy this to the hard disk folder of our router. So okay, so I need to verify the host. So let me go to sudo nano, and let me see the content of let's so I need to basically delete. I think there is a change in the SSH key presented by the router, so I might have to delete that in order for the box to accept the new key. So let me go ahead and delete this. So I'm hoping that this is the line for the router. So now that I have deleted it, hopefully things should work, and I should be able to copy the file to the XR router. So let me save this file, and let me add the new certificate. So we have successfully copied. Now let's come back to the XR router and see the contents of the hard disk. So here we can see that the CA file that we generated on the Linux box is now available on the XR router. So the next step that we're going to do is to copy this ca.pem file, which is there on the hard disk, to the appropriate location, which is basically the directory or the config directory for the GRPC application. So I'm going to source this. So ca.pem is the source file, and I'm going to copy this to a destination, and the correct folder for this is under miscellaneous configurations grpc, and inside this there is a folder called dialout, and I'm going to save this certificate as the PEM file for dialogue. So this is one of the means by which I can ensure that this certificate chain of root CA is available for GRPC process to check whether the server certificate is a valid certificate or not. So cannot. So I think there's a spelling mistake somewhere. I'm just checking for the error. So what's the problem here? No such file or directory. Okay, so I think we have not configured or initialized the model driven telemetry process here. So show run telemetry model driven. Yeah, that's right. So let's do one thing. Let's come back to this step after configuring the telemetry process. So let me start by issuing the commands. So let us key in the same commands that we used earlier. This is okay, and the protocol that we're going to use is GRPC, and this time we're going to use TLS host name, and we're going to give the host name that we have chosen for our certificate. So this should be good, and we also have to configure the sensor path, sensor group basically. So I'm going to use the same configuration that we used in our earlier videos. So I think this should initialize the directories, and we should be able to copy in a matter of time. So let's give it a couple of seconds. Meanwhile, let's go to the telegraf server itself, where we need to configure these certificates. So let's quickly take a look at the telegraf configuration file. So it's under etc telegraf and telegraf.conf, right? So this is the configuration that we presently have, and we need to add two lines basically, and this is the part wherein we say, so you need to enable TLS for the GRPC communication which you're listening on 56999. So telegraf server expects two files to be present in this directory, which is the cert as well as the key. So it's our duty to copy these files to that appropriate destination. So what I'm going to do is I'm going to copy the telegraf certificate. So I'm going to, so this is the telegraf key file. So I'm going to copy, I'm going to copy the telegraf.key file, and I'm going to put it in etc. So let's do one thing. Like before we copy the content, since this key is a protected file, let's unprotect the key file before we copy it there. So let me just do a quick Google search, OpenSSL private key. Yeah, so what we'll do is open SSL RSA. We'll input the original key, which is telegraf that lab.key, and we'll output it to what's the name that we should use. I think we should use, just give me a second. We'll use key.pen. So we have got the key.pem here. So now let's copy this and copy this key.pem to, so since this is our write protected directory, so let's use sudo and /etc telegraf, and also we need to copy sudo the telegraf certificate itself. So telegraf dot lab dot pen. I think I missed the copy, and I'm going to put it inside etc telegraf, and this is going to be cert not pen. So I think I made an error there. So I'm going to modify this to cert pen. Yeah, so I think we are good with respect to certificate. So let's go to /etc and slash telegraph, and then see the content. So we would want to remove the word.pem. I think, um, yeah, now we are good. Let's see the permissions here. So you can see the cert.pem has the read permission, but key.pem does not have that. So let's quickly modify the permission. So rw rr, what's the chmod command? So we need to modify the chmod 644 key.pem. So we'll do sudo, and yeah, now the permissions seem fine. We have got the keys, we have got the certificate. So let's see sudo system ctl status telegraph.service. So this active. So let's try doing a restart if things are working. So things seem to work. So we have enabled telegraph and it's listening on port, and we'll grep for 64999. Sorry, I think 56999. So it's listening. So things are perfect with respect to telegraph server. So I think we have not copied it. So I think since we have done this step, so now this time we should be able to. So once we have done that, we can go to the shell and then verify whether we have placed the file in the correct directory inside GRPC. Let's just see this. Inside GRPC we have dial out, and here we have got the dialout.pem, which is the certificate that we actually require. So now this part is done. So now once we copied this, we'll have to restart the EMST process. This is the process which is responsible for model driven telemetry. So we'll restart this process. We'll give it a couple of seconds, and we'll also check show telemetry, model driven, and followed by summary. So we still don't have the sensor path resolved. So this is the first step that happens once we restart it. So we'll have to give it a couple of seconds for it to get resolved. So once it is resolved, then it will attempt the communication, and we have to see in this destination. So you can clearly see that we are presently using GRPC TLS. So this is okay, but this subscription is presently not an active state. So we expect this to come in the active state. So this is presently in the connecting state. Now it is connected. Now the stream has become active. So what's important here is that we also verify the configurations that we have done. So here, show telemetry, model driven, and followed by destination. So we expect to see the TLS to show the host name that we have, which means that the configuration is right and it's working. And another common command that we can use to verify whether things are working okay is to use the GRPC trace. So this command will basically help us identify if there were any errors, and you know you can clearly see if there were any errors. It would show up in this particular trace. And one more command that becomes important when verifying the configurations would be show telemetry model driven trace. And so this go info will also let us know, the steps that the process undertakes, and we can clearly see how earlier we had configured, but configured TLS, but but no certificate exists, right? Because we did not have. And then we placed this certificate here, um, and then the TLS is now true because now we have a certificate here. So all these steps you will be able to trace out in this by this mechanism. So one more thing before we close out this video, we would want to see a packet capture. So let's just refresh our edge shark, and we'll see how the exchange is happening between the router and the telegraph server. And we expect this communication between the telegraph server and the XR router uh, to happen over TLS. So let's verify it by means of a packet capture. Let's wait for a couple of seconds for this to load. So as you can see, we'll just stop this. So you can see the exchange between the router and the destination is happening over TLS 1.2, which is what we expected. So here you can see in the last videos when we took packet capture, we could clearly see what was being exchanged. But now, since we are employing TLS based security, we can see clearly that the traffic is encrypted. Now let's come back to the influx DB, and let's verify if we are actually obtaining the data. So the influx DB runs on 8086, and I'm going to go in to the data explorer just to verify if things are okay from InfluxDB point of view. So in XR, let's quickly check the input packets received. So I'm checking this for 0000, and the host name is XRD1. I'm interested in this subscription called interface stats. So you can see the packets is 4. We can verify by just pinging the other destination that I have. So I know I'm sending 5 ICMP packets. So I expect to see at least 5 ICMP replies. So this should have increased a bit now. Let's go back to InfluxDB and check whether this is increased. So I think we might have to wait for a couple of seconds before this changes. So I'm just going to drill this down so you can clearly see that it increased, and now the new value, earlier it was 4, we sent 5 ICMP packets, and the new value now is 9. So now we've verified couple of things. The data exchange between the router and the server is now happening over TLS, and also we have verified that the data is actually properly working. So that's it for this video. Thank you for watching. I hope this will help you in implementing TLS based security for your production networks. Of course, you'll have to be careful when implementing the certificates and certificate chains, and you'll have to also be careful about the way we store the keys along with the passphrases. And the most common implementation would not use the private CA, but it would use the enterprise CA for all this. So thank you so much for watching. Have a good day.